All right. You all have met me, so we're going to do Speedrunning DevOps, what not to do in 5 minutes or less. You all are now representatives of a company. You're employees. And this ship needs to turn around. And so guess what? I am now your new CTO. Yeah, all right. We're really excited. I keep hearing about this thing called DevOps, and I think that's how we're going to fix everything. So the very, very first thing we're going to do is we're going to go out and we're going to buy DevOps. I've already talked with Microsoft, I think it's Microsoft, right? And I talked with CloudBees. We're going to pick something, we're going to implement it, it's going to be great. If I can get my narrator hat on. I'm now your narrator. You can't buy culture. It's not stuff. You need to do the people work first and the process. Okay, now that we've implemented DevOps by buying it, because that's the perfect thing to do, I heard about all these buzzwords the last time I talked with all the CTOs. So you all are now the DevOps team. You all are now the SRE team. You all are all the platform engineering team. And you people in the back, I keep hearing about this thing called AI Ops. That's you. So now we have all these different teams. Guess what? Silos don't fix communication. Adding more teams won't do anything. So maybe don't do that. All right, now that we've done that, I keep hearing about like security and QA. This is called DevOps, which means it's just devs and ops. We don't need security. This company's not worth breaching, right? The whole idea of DevOps, and I'm going to stop trying to put the hat on, is that everyone should be involved from the very beginning. That's the shift left idea. So, security, QA, marketing, everything is part of it. Okay, now that we've done all this different stuff, we need to make some shiny new dashboards. We're going to have every metric under the sun, everything we can possibly measure. We're going to make these dashboards. Our CEOs are going to be so excited, so we're going to spend the next 6 weeks building them. So, oh, my lines didn't come out. With over-measurement comes obsession. Know why you're picking the metrics that you do, and be able to tell a story around them. Otherwise, they're meaningless. So guess what? I went to a workshop last night, and I know I asked you to refactor last week and the week before and the week before and the week before, but this new tool is going to fix everything. So we're going to go refactor again. It is going to be perfect. Guess what? Fix your process first. Picking out a shiny new tool won't solve your problem. That is called shiny tool syndrome. Don't do it. Okay, now, we're going to automate everything. And I mean everything, because that's DevOps, right? It's all automation. So not just our pipelines, maybe some code review, stuff like that, but we're going to automate you drinking your coffee, like the Jetsons, right? This is going to be perfect. DevOps isn't just about automation. And please don't automate me drinking my tea in the morning. I might chip my teeth. I think you figured this one out by now, as I lose my time. We don't need any titles. Everybody tells me that developers can do everything. So I know I just put you all on all those teams. Now you're all developers, and you're going to own your infrastructure and your code and the marketing, all of it. Specialization helps. In the DevOps world, it's not about making everyone a generalist. It's about valuing all of the specialists that you're working with. Maybe, possibly. So, I hate to tell you folks, I had to call this all hands. We had a breach last night. Why did we fail? We did everything right. I can tell you why. You all failed me. The fact is that you need to build in and build up psychological safety. Failure breeds innovation. If you want to be able to fail safely, you can move faster. And that's kind of the idea. So really, folks, the road to DevOps hell, the toxic cultures, the toxic bosses, the stories that you tell the wide-eyed junior engineer asking you about what happened when, this road to DevOps hell is paved with your good intentions. Hit the brakes. Take a moment, think about what you're doing and why, and don't fall for shiny tool syndrome. Thanks.
That was Excellent. Excellent. All right, we've got Carl Chester coming up to do diagramming as code. All right.
All right, hi everyone. I am Carl Chester. I'm an engineer at Oracle, and I'm going to be talking to you about diagramming as code, a way of conveying information about our systems through diagrams, but managing it through methods how we do with code. So hopefully you'll take away something out of this 5-minute talk to apply in your systems. Quick, tell me where the system single point of failure is in the system. Where is the system single point of failure? Tell me. Both of them are conveying the same information, but one is highlighted in a diagram that you can see quickly because we are visual creatures. So what is diagramming as code? It's a philosophy of how we're going to manage kind of diagrams with the same tool chain as we do with code. This aligns with docs as code or documentation as code. So you may ask, well, what is documentation as code? Well, it's pretty much, I would say, categorized by some properties. One, it's kind of authored in plain text like Markdown. You can manage it with your same kind of code. It's in version control, so you can easily make changes with it. You have it in your code reviews, so you make both changes, and it's also managed with your issue tracking of code changes. So in this talk, we're going to survey really quick 5 tools. We're going to talk about GraphViz, Mermaid, Diagrams, D2, and Draw.io, which is a different kind of tool that also manually manages your documentation and diagrams. So GraphViz, this is the grandparent of them all. It's been around for over a decade. You can clearly kind of describe kind of a directed graph through this, through some language like this, and it can build out a nice visual of what that is. There are tons of tools that output this kind of syntax. Mermaid, this is extremely popular, a new one, which you can build tons of different diagrams with this in a lot of different types of tool chains. We'll talk about some of those integrations of what that looks like. So the first ones you may see is a typical one we just had. A typical like directed graph, you can make a flow chart with the same kind of symbols and it can illustrate that diagram you have down below. It makes it very easy to kind of describe dependencies, the classic box and arrows. You can describe a lot with boxes and arrows, but it also has tons more support and tons of diagrams. So you can do tons of different things about illustrating your systems by keeping that documentation of your diagrams close to your code. Proximity is key in maintaining documentation like diagrams. Mermaid also has tons of integrations. VS Code, you can write right within your editor and it can give you the actual preview of that diagram on the right-hand side. GitHub, it's baked in as well, so you can put it in your Markdown, also in comments and code reviews. It also can be understood by generative systems. So you can describe something, and the machine, which uses the language to communicate back to you, can describe it in a diagram. So in that language of the illustration of dependencies, you can actually take that and move it into something visual. Diagrams is another project. It's a Python package that can do some really nice illustrations by describing it in code to visualize your system. It utilizes GraphViz. Remember, our grandparent of them all? So in diagrams, here's an example of doing that same system I had earlier, but doing it with some nice, beautiful color illustrations if I'm using AWS. But as you can see, you can do some simple declarations of what that is, and then you can use this program kind of in flight of a Python, execute that program, and generate it. It also has a sweet inventory of all these different icons you can use. So you have things from both Kubernetes, all the public cloud providers has their icons built in as well. So you can build even better kind of understanding of systems by using those icons. And next, we'll talk about D2. This is a brand new one that's more of another way of declaring systems in diagrams like this. So in this kind of illustration, we'll talk about another similar diagram you can use in D2. D2, as you look like, it's very similar language you can have before and make that nice, similar kind of representation of what it is. So that kind of directed graph view of it. But it also has a lot of other nice features, too, for how you can theme those type of diagrams and animate them. So in this example, you can build out a visual that we want to have, maybe put that sketch theme so it looks like you did it on a whiteboard, but you really didn't. But then also make it so we can visualize and use animation to show information flow. Remember, arrows talk a lot about a system. And last, Draw.io. This is a classical diagramming tool that you can use locally. So you can use Draw.io desktop and run some of these diagrams yourself. The beauty about this is that it understands some of this language as well. So if you haven't seen this before, Draw.io can do an advanced import. I can import in actual Mermaid type syntax So that big graph I had earlier from what ChatGPT gave me about a big graph, I can pull it in and put that nice finesse I want on top of my diagrams. So as a final recap, there's a lot of sweet tools you can use that are GraphViz, Mermaid, Diagrams, D2, and Draw.io. The key thing to take away is you can manage diagrams and describe systems with your code base, and you can keep it up to date better if you keep it close to code. Proximity is key. So thank you, and hopefully you can diagram more and describe your systems visually, because remember, we're all visual creatures. Thank you.
That's great. All right. Excellent. All right, next, got AJ. Talk about on-prem is the new black.
Hello. Okay. All right. Hello, everyone. My name is AJ, and today I'll talk about why reverse migration has been the cool new thing these days. So initially, cloud was meant to cut costs, right? So the subscription fees were straightforward, and maybe you had a couple of hidden costs, maybe the transfer fees and all of that. But then you also end up with this proliferation of unused resources that just languish without proper management, right? So, and the cloud companies, they actually thrive on this lack of optimization. Is this going? Okay, all right. So, right. Oh, I think I'd hit play up there. So if you autoplay and then play? Yes, okay, there we go. Okay, so cloud companies are actually, they know that the applications are not optimized, so, and they make a lot of money out of this other lack of optimization, right? So knowing how to optimize is the first step. And initially, if you have, a startup with a few apps and you're just starting to figure things out, it's okay to use cloud, but as your app grows, right, linearly, your cloud costs are going to grow exponentially, right? And you'll end up in a situation like this where most of your resources are wasted and you're only using like a portion of it to actually run your applications, right? So I mentioned you could use cloud initially for the smaller enterprises, but also large enterprises who maybe have a diverse need for, rather than buying hardware, it makes sense for them to use cloud as well. So ultimately, it's use case specific. Okay, raise of hands. How many people here think that Jeff Bezos became a billionaire by selling books? Good. I expected no one to raise your hands because, we have to sort of rein in those costs, right? So first thing you can look for, maybe bringing in like AI, ML workloads, right? Maybe like a GPU processing and anything which you can build locally and have more control over your models, right? You can run it on a Kubernetes infrastructure and anything where you can have it homogeneous over multiple environments, right? Whether it be hybrid cloud or multi-cloud. So you want to make sure that you want to have those tools in place. And what are some of the challenges of repatriation? So the lack of on-prem hardware knowledge and the initial hardware cost, and just harmoniously working with the rest of the infrastructure, right? So to aid with this, think of cloud as not like a location, but like an operating model. So no matter where you have your infrastructure, multi-cloud, hybrid cloud, in Kubernetes, make sure the processes are homogeneous and you could use a similar process across. So to start to think about this, think about where you're going to store your artifacts, how are you going to build them, the CI/CD pipelines, and versioning your infrastructure as code and your provisioners, and also making sure you have some model to build your application, right? So an example of this would be if you pull from an upstream image, you would build it locally, and then you would push it to your registry and maybe test it a little bit, and then you'll use something like Terraform to provision it on your infrastructure. And these images can be, you can either build it, completely with your API and web, you can bake it in, or you can fry your image in a way where when it boots up, it's going to install the application, right? So in a diagram, it would look like you'll pull it from upstream, you would build it, and you'll push it to your registry, and then you'll pull it back from your internal registry to build your layer 2 application artifacts. I'm not endorsing any of these tools, by the way, but some of these things you need to think about are how are you going to build your image, how to test these, where to store the secrets and your artifacts, and what are you going to use for infrastructure as code. And think of your infrastructure as cattle, right? Like, make sure everything is backed up, you have replication set up, make sure one infrastructure going down is not going to take your entire application, right? So make sure you have redundancies in place, and make sure you don't put all of your stuff in a public network. Make sure you have different networks, like an ops network, air-gapped network, a public network where you can your APIs and web applications could go, and maybe your storage and databases should go in an air-gapped network, right? And even if you are geographically dispersed across multiple regions, you can have these different networks in each site, and then you can link them using a dark fiber or some other way, right? And so the three main broad categories you want to think about is your on-prem hardware knowledge, and think of cloud as an operating model, and just using native cloud rules across your different environments. So am I saying, okay, close all your cloud stuff and just go out? No. I'm just trying to start a conversation where think about what makes sense to move on-prem, what makes sense to be in cloud, and then go from there. And that's my time. Thank you.
And our last one is Nathen Harvey with DevOps, A Way of Being.
All right, apparently I'm a historian today, so we're going to go back in time to when I was a child. When I was a child and I listened to music, there were rock bands and there were rap bands, and they never worked together. And over here we have a rock band, and the operations people are really angry at this rock band. They're banging on the wall. And at some point, one of the developers got curious. What's happening over there in operations? And they got so curious, they kind of punched a hole in the wall, and they looked through, and they said, what is going on? You keep breaking everything that I throw through this wall. What is your problem? It works fine on my machine. So they're looking through, and operations is being like, oh, it's you. You're the one who keeps throwing that shit over the wall. We're not very happy with you. So what do? They break down the wall. And what happens? The operators come over and they join the developers. But here's the thing, the operators didn't pick up guitars and start shredding. The developers didn't start freestyling rap lines. No, they kept their specialty and they worked together to please the audience. How did this happen? This all happened by the originator of DevOps, a gentleman, a music producer, a philosopher by the name of Rick Rubin. Rick Rubin is the one who had this idea to bring Aerosmith and Run DMC together. Trust me, there was a lot of hesitation on both sides of the house. But when he did, he fundamentally changed how we all experience music. Today, Rick tweets all the time, and he drops philosophy about DevOps, and I'm sure he's never heard that word. Thinking doesn't always solve the problem. Sometimes creating space allows inspiration to do the work. How is that not DevOps? We just have to create some space. Maybe we get together. Quality over deadlines, said every CEO, right? We always want quality over deadlines, but this is a DevOps approach to what we're delivering. We want to deliver that quality, and Rick knows it, and he's encouraging us to do so. The reason to finish is to start something new. Rick even knows that the thing that you should prioritize is flow through the system. Minimize your work in process. Work on one thing, get it done, get it deployed, then you can pick up the next thing. Do you want to be right, or do you want to do what's best for the work? Let's do what's best for the work. And the work is creating great experiences for our audience, for our customers. We should take inspiration from this and remember that we're here to deliver great business value. Some can see the end the day they begin. Others can't see it until it's upon them. One is not better than the other. He even compares waterfall and agile. But he's not always right. Rick is not always right. All right, next up, with every piece of advice, consider sometimes the opposite is equally true. So you have to think critically about what you're doing, how you're taking, even what you're hearing up here on this stage. How are you going to apply that within your own organization? Average is not anything to aspire to. Come on, I know that you can be better than average. You can do it. Do not aspire for average. Be the best that you can be. Always see if it can be better, and always check back to make sure you didn't ruin it. Look, forward progress is great, but you've got to make sure that you're still delivering on the value that you expected, that you're keeping your customers happy. The best work is nearly inexhaustible. It withstands experiencing again and again and again. Have you ever met a compliance officer or had to deal with security? Yes, it's inexhaustible. If it's your best in this moment, that's the best it can be. But don't worry, tomorrow, your best may be completely different. So show up today and do the best that you can. Tomorrow, you might be doing better, you might be doing worse, but do your best tomorrow as well. Aiming at greatness is different than aiming at being better than someone else. Don't let comparison be the thief of your joy and your improvements. Do what you can on your team to drive things forward. Allow the individual pieces to retain their natural voice. This is DevOps and DevSecOps and DevFinOps and DevCustOps and DevQAOps. We bring those specialists together and we allow them to thrive in collaboration. And then finally, I want to set you up for open spaces. If you are speaking, or if you're listening or speaking, either way, you are participating in the conversation. Keep that in mind as we move into open spaces. And I encourage you to take Rick Rubin's advice. DevOps, just like the creative act, is a way of being. Thank you very much.
Go.
All right, so physics as a philosophy for practicing life. And when I say for practicing life, I can mean like anything from DevOps life to your actual life to just washing the dishes. But one of my favorite classes was quantum mechanics. It was also the hardest class. It looked a lot like this all the time in my brain. And I learned one of the most important lessons in that class, that everything is relative. Absolutely everything, from your forces to how you feel about other people to the conflicts that you manage on your teams. It's all relative. And I have this lovely Newton's second equation because, of course, we're going to start at 2 instead of at 1. And we're going to talk a lot about force, about the other side of the equation, the mass and the acceleration. But when I tell you about it, it's going to give you a little bit of clue into like my worldview and how I think about people. So for force is, that thing that happens, like if I jump up and down, gravity's got me, it's a force. It is also, there's mass and acceleration. So mass is, me, yeah. And acceleration is whether or not I'm moving and how fast I'm going and how far I'm going over time. I will also break these down a little bit more. Don't go tell my professors that I'm doing very fuzzy math. Please and thanks. So force equals mass times acceleration. This is the law of inertia we're talking about first. This is an object at rest, tends to stay at rest until it is acted upon by another force, an outside force usually, right? So me standing right here right now, I'm pretty solid. But how many of you are actually inertial at work? Content, so you thought, right? Or you're not getting to where you need to go? Is it because you're not moving? Is it because, let me just do my job? Or did you need that external force? Somebody standing over you to maybe give you a swift, what are you doing? It could be anything, right? That external force could be your boss. It could be a reduction in force coming. Something, though, is probably coming to get you moving. The law of action and reaction. For every single action, there is an equal and opposite reaction. It doesn't really tell you which direction opposite is, though. So I like to think about it as the ability to pivot. If something happens, do I have to move 180 degrees? Not necessarily. Not necessarily. Have any of you shot pool? Shot pool? So billiards, when you hit that at a certain angle, give it some spin, some English, we're moving in a different direction. The other part of this that I love is energy. Energy equals mass times the speed of light. And with the theory of relativity, there's like the special theory of relativity and like the regular theory of relativity. It's all relative. It's all relative. So like, say for instance, is this a mountain? Is it a street? How far away is that ball? Or is it just, a kid playing? Perspective is everything. What that little gold ball is to anyone is viewed through the lens of their own experience. And that problem might not be a problem for you, but it's a problem for them. So thinking about conservation laws. You see my good force and my energy equations go by. Energy and force, they're the same. Conservation of energy. So I cannot just make energy disappear, and I can't just create it, but I can transfer it. And we're going to talk a little bit more about transferring of energy and giving your energy to people, to things, when and where and why maybe you should do that. I think about it, like I said, it's everything being relative. So if something happens to me, I get terminated, yeah, I'm probably going to be upset about it. I'm going to feel away. But how much of my energy am I going to give to that situation? How far do I want to go? If I think about it, I'm a force, right? I'm a force, you're a force, your team is a force. We all have the ability to impact each other. And I think that often we will give our energy to things and people that we shouldn't, and we don't give them the levels of which we should. Sometimes we're not giving family the appropriate energy. We're giving it all to our job. Sometimes we are we're the stable thing, and we need someone to give energy to us. I can't pour out all the time. Sometimes I need someone to pour into me. And sometimes when we are viewing things that are, is this really a conflict? Is it really an offense? Why do I feel like I'm taking offense to that? Why do I think that you're coming at me, bro? What if you actually aren't coming at me? What if my perspective is just off? Everything is relative. So before you leave, that is one of the things I really would love for you to get. This is kind of how physics has managed to just shift how I think in a way that I'm able to take myself outside of a situation, flip that perspective and see, hey, what else could possibly be wrong with this? Because everything is relative. And I don't know if I need to give my energy to that. And I think that everyone should choose to move your energy wisely. Think about what you're pouring into, why you're pouring into it, whether or not you should pour into it. Take it back if you need to. Keep that in mind.